Thank you, sir, for all your nice words. And I also thank all the organizers of this program for inviting me to this platform. And thank you for that. Okay. I hope and I believe that I am audible to you all. Am I?
Yes, ma'am. Yes, ma'am. Yes.
Okay. If at any time I lose my connectivity, please let me know, okay? Because I am speaking from a place where I have network issues. So kindly please update me if you are not clear with what I am speaking, okay?
Okay, ma'am.
Okay. Now, see, we have almost 90 participants here, and I find we have a cross section of participants. We have students, research scholars, and also we have people with PhD degrees. So it's a mixed community, and I'm not sure actually whether I'll be able to serve a cup of tea to each and every one of you here because I am asked to make a presentation on basics of econometrics. There might be persons, there might be experts here. Might be this presentation might not be much useful to people who are standing at a high end. So because I am just dealing with the basics of econometrics, that's what I'm asked to do. But in case if you have got any clarifications, any feedback, please feel free to communicate. Okay. Now, without wasting much time here, I'm just moving on to the presentation. I'm just trying to share my screen. Please help me with the feedback of whether you are able to see it or not, okay? Now, is this visible, my screen?
Yes, ma'am. It's visible.
Okay, thank you. Now, today we are dealing with the basics of econometrics. Okay. Now, I'm damn sure that each and every one of you here know what is econometrics, at least what is meant by econometrics. See, econometrics as such is not a independent subject. Actually, it is a combination of three different disciplines, three giant disciplines. We have combined three giant disciplines to form a new area known as econometrics. So being the basics here, I'll be just dealing with three things. One is what is econometrics, why you need econometrics, and what is the methodology of econometrics. That's the main content of this presentation. And moving to what is econometrics. Econometrics is the application of statistical and mathematical tools to economic data. Actually, what we do is we have combined three subjects: statistics, mathematics, and economics. Econometrics is a combination of all these three, that is statistics, mathematics, and economics. What we do is we apply the statistical and mathematical rules and tools to analyze the economic data for the purpose of taking rational decisions or for the purpose of taking genuine wise decisions. That's what we do in econometrics. Now, the pertinent question is, see, these three subjects, that is statistics, mathematics, and economics, as such, has got its own independent status. Okay, it is three independent identical disciplines. Then why do we need to combine all these three to form a new segment known as econometrics? So what is the need of combining all these three? So that's what I'm going to explain next. Actually, the problem is with first we'll deal with economics. Why? Because econometrics starts with economics. When we deal with the methodology of economics, the right from the first step, what we do is we derive the laws and the theories from economics. So here also, when we are speaking of why we need econometrics, we are starting with the subject economics. What is the problem with economics as such? See, as such, economics don't have any problem. But the issue that we face in the case of this discipline, that is economics, is that, see, we know that there are many theories and there are many laws in economics. See, law of demand, that's one of the basic thing that we start learning when we start with our economics in our school level itself. What does the law of demand says? Law of demand says that when price goes up, demand comes down, and when price comes down, demand goes up. So it explains the relationship between price and demand. Now you have got law of supply that again deals with relation between two variables, that is quantity supplied and price. So economics deals with the relationship between different variables. But the problem here is economics only gives the direction of relationship. That is, when one is coming down, the other is going up, or might be both the variables might follow the same direction. You call it as positive relation. So it gives the direction of change, but it never tells us what's the magnitude of change. For instance, when you're saying that when price comes down, the demand goes up, it only gives the direction of change. It never says that if the price comes down by 10 rupees, to what extent the demand will go up. That is not answered in economics. That's the issue that we have. That's the issue that we have in economics. So it gives the direction of change, but it will not specify what is the extent or what is the magnitude of change. So most of the economic laws and economic theories are qualitative. And what happens is qualitative indicators are least sufficient for taking rational decisions. See, better decisions and the best decisions can be taken if we have got quantitative indicators. But economics as such fails to give a quantitative expression for these laws and theories. Okay, there are very good laws, there are very good, these are all very good theories in understanding the real life situations. The law of marginal utility, we have it. Okay, but in all these theories, the problem is we don't have a quantification of what is mentioned in the law or the theory. So that's the issue that we face with economics. Now coming to mathematics. Mathematics, as Biju sir has mentioned in his opening remarks, the problem is mathematics assume that there is an exact relation between variables. Now, what is an exact relation? What is meant by exact relation? I'll explain a little bit more when I am starting with the methodology next slide. Okay, so for the while I'm just leaving it. The problem is that mathematical model assumes that there is a very concrete and exact relation between dependent and independent variables. In fact, such a thing will never happen in a real life situation. Especially in social science, what we see an inexact relationship between variables. You can never well predict what is the relation between two variables so concretely and so confidently with the help of a model. So there exists no exact relation between two variables, but the problem with mathematics is that it assumes that the variables has got exact relation, and I'll explain more on what is it when I am dealing with the methodology. Okay, now what about statistics? Statistics is a very good subject. It's very helpful. It's very helpful in forecasting, predicting things. It's good, but the problem is statistics is only an end part. Okay, here research scholars, we have research scholars here, we have students here. You might be doing a project and research work. Actually, where is it we apply statistics? We apply statistics only when you have a data with you. We need statistics only for an analysis. So statistics is only an end part. So it can be it can only supplement to what we have. If we have got good data, we can also have good statistical analysis. So as such, all these three subjects has got their own utility, has got their own benefits. But the problem is that uh, if you want to have very good decisions, if you want to have very good predictions, you need to combine all these three subjects. Okay, so we have econometrics to deal with the limitations of these three subjects. Okay, limitations in the sense in the context of decision making. Okay, so econometrics will help us to predict future economic trends such as economic growth rate based on historical data. And these three combined, when we combine it together and when we form with to econometrics, this segment or this discipline will help us to take good decisions. That's why we are combining these three disciplines. Okay. Now, next is we are moving on to the methodology of econometrics. Just I have mentioned in my initial remarks, actually the methodology of econometrics or the steps how to deal with this or how to start a connection with the subject all starts from economics. Actually, we need a theory. It's with the help of a theory that we progresses. So the base of econometrics is in fact the economic theories or the laws that we derive. Okay, as I have told you, there are many laws, there are many theories. Like there is certain few examples I had given here. Marginal propensity to consume. Actually, this specifies a relation between income and consumer spending. Here, income is the independent variable, and consumer is the dependent variable. It says that when you have more income, your spending will also be more. If your income comes down, naturally your spending will also come down. So there is a direct relation. So here, what is the problem with economics here? It gives you the direction of relationship, it gives you the direction of change, but it will not specify what is the extent of change. That is, for what change in income, what change is caused in consumer spending. That quantification is not possible in case of economics. Now take another example. You have law of demand. I have already mentioned it. It specifies a relation between price and demand. When price goes up, demand comes down, or when price comes down, demand goes up. So there is a inverse relation, or we call it as a negative relation. Okay, here also you have the direction of change, but we don't have the magnitude or extent of change. Similarly, you have the law of supply, you have the theory of diminishing marginal utility. In all these cases, what happens is we have the direction of relation, but we don't have the extent or magnitude of relation. That's why economics will not serve our purpose in the context of decision making. So what we'll do is we'll move on to the second step. The second step, actually, we are trying to quantify these economic theories or laws. Okay, we are going to have a quantitative expression for this, and mathematics will come to our help. See, this is specification of mathematical model. Why? Because at the first step, we started with our economic theory, but the economic theory was itself insufficient to help us in a concrete decision making. Now we have sought the help of a mathematical model here. See, y is equal to a plus bx, or y is equal to alpha plus beta x. See, this is a linear equation. We are familiar with this. Right from school levels, we have been solving all this. See, some authors might use a and b here. Actually, see this one, a and b. Some others might be using alpha and beta. In fact, both are same. One is in English alphabet, the other was one is a Greek expression, but both means the same. And a and b, or alpha and beta, are known as the parameters of this equation. Okay, a and b, or are alpha and beta, are the parameters, and our effort or our attempt is always to estimate these parameters. Okay, now what about the other two, that is y and x? Y and x, y is your dependent variable and x is your independent variable. See, for example, if we are taking the first one, see, marginal propensity to consume. Here we have got two variables, income and consumer spending. Here income is your independent variable and consumer spending is your dependent variable. So when you are putting it in the form of an equation, y will represent your dependent variable, that is consumption, and x will represent your independent variable, that is income. Okay, so y and x, I hope it is clear. So y is your dependent variable and x is your independent variable. Now moving on to detail as to what does a and b or these parameters mean. A is called the intercept and b is known as the slope. Now what is intercept and what is slope, I'll explain to you with the context of this particular rule or the theory. So we are dealing with two variables, that is consumption expenditure and income. Now what does A and B do here? See, B is slope. What is slope? Slope is the ratio of change in Y over change in X. That is, what is the changes happening in Y? Y here is your consumption expenditure. So what is the changes happening in Y as a result of the changes happening in X? Or how does X influences Y? So slope defines the relationship between Y and X. So if a change is exhibited in Y, what is the extent of change that this X has been able to make on Y? Okay, so that's what slope defines. Now what is intercept? Intercept defines that even when X is 0, what is the value of Y? For example, see, suppose X is what? X is your income. Income is zero. You don't have income. But even then, you will have a minimum consumption. You might be consuming from some other sources. Sometimes your friends might feed you, or sometimes your some kind of charitable societies might feed you. Sometimes you might have some kind of agriculture products at your home, so you might be consuming something. Sometimes your friends might help you with some pocket money or something. So here actually income, you don't have any income, but then you will have a minimum level of consumption to sustain your life. So A, what does this A tell you? What does this intercept tell you? It tells you that what is the value of Y when the value of X is zero? Or what is your consumption when you don't have any income? That's what is defined by A or intercept. Okay. I'll just give you once again. See, A is the intercept. A attempts to tell you what is the value of Y. That is, what is your consumption even when you don't have any income from any source. Okay. So what is the value of Y when X is 0? That is what is defined by intercept. What is slope? Slope clearly explains what is the change that X could make in your Y, or to what extent X has influenced your Y. So these are the two parameters, and hereafter we will be calling these as parameters A and B. These are parameters. Okay. Okay. Now, the problem here is actually this is a mathematical model. Now, this actually explains that for whatever changes that's happening in Y, only X is responsible. That is, if X is going up, Y will also go. If X is coming down, Y will also come down. Okay, this is solely depending on your income. That is, consumption is solely depending on income. This is known as an exact relationship. Okay, we know that this is not a reality, because income is not the only factor that might affect your consumption expenditure. See, even when you are not working, or even when you don't have regular income, you might be consuming. It may be because you have got family wealth. It may be because you have got certain other irregular source of income. There are so many other things. Okay, so in real life situation, it is not true to say that your consumption solely depends on your income. Thus, what I mean to say is, in reality, we'll never have such a kind of exact or deterministic relation. There are so many other factors other than income which affects your consumption. But the fallacy of mathematical model is that it never takes into account these other factors, or we call these other factors with a sweet name known as extraneous variables. The mathematical model will never take into consideration those other factors. The mathematical model only focuses on your X. So that is the fallacy of mathematical model. So now when we are moving on to the second step, actually now we understand that mathematical model is insufficient to deal with many of the aspects of real life situation, because we fail to find an exact relationship in a real world situation. So now what we do is we move on to the third step. Okay, see, this is only for your understanding. Now see, last step actually we were dealing with dependent and independent variables, so might be it's possible that there are different terms associated with this. Certain authors have used certain other terms for dependent variables: endogenous variable, predictant variable, and the explained variable. These are certain other terms that are used for dependent variable. And for independent variable, exogenous variable, predictor variable, explanatory variable, it all means the same. Okay, it is just, I have just shared the screen for your understanding. Okay, now I am just moving on to the third slide. Actually, in the second step, we had a mathematical model. Okay, second step, we had a mathematical model, and as we have seen, mathematical model had its own limitations. Now we are coming to our econometric model. Actually, what did I add here? I have added an alphabet known as called U, and this is known as U term, or this is known as an error term. Now what does this mean? Actually, this is added here. This is an umbrella term. Actually, this is added here to represent all those other factors which might affect your consumption. but which is not represented by X. So X represents only your income. But in real life situation, we know that income is not the only factor which affects your consumption or which affects Y. So in order to combine or to bring together all these, we have added another term, and this is known as your U term. This is known by many other terms like random term. This is also known as error term. This is known as a disturbance term. Why? Because actually these factors causes a disturbance in the relation between Y and X. Okay, this causes a disturbance in the exact relation between Y and X. So this is also known as a disturbance term. This is also known as a stochastic term, because that creates irrational movements in this relationship. Okay, so what does you do does here? You actually does is it acknowledges the effect of all other variables other than X which have an effect on Y. So this U term is a umbrella term to incorporate all other extraneous variables. Now you must know why you should include this U term. Okay, can you see this Word document that I have shared with you? Excuse me,
Ma'am, not visible, ma'am.
Ma'am.
not visible. Okay. Now, can you just see it?
Ma'am.
It's visible.
Okay. Yes, yes. Okay. See, I just want to make a brief explanation on why do you need to add this U term or error term. That is, instead of X or instead of your main variable, why do you need to add this error term or the stochastic term? Okay. See, the first thing is the theory itself is vague. Vagueness of theory means, see, in our example, we have taken a theory wherein we state the relation between consumption, expenditure, and income. But we know that income is not is the we know that income is not the only factor which affects your consumption. But at the same time, the issue is that we are not sure of other factors which might affect the consumption. So such things happens. The theory itself is weak because the theory just gives a relation between two variables, consumption and income. It never specifies about other factors which might affect your consumption expenditure. So as such, there is a weakness in theory. You are not sure of the other factors that might affect consumption. So what we do is, instead of building up a multiple regression model, what is a multiple regression model? Instead of 1x, you will have more than 1x. That is, see, y is equal to a plus bx. That's what our formula is, our equation is. So instead of bx, we will have bx1, bx2, bx3, which means that there are so many other independent variables. So in case of multiple regression models, we have more than 1x. Okay. So at certain times, what happens is you will not be able to clearly define what are the different x's that might influence your y. So what we'll do is we'll place the main factor or the main variable as x, and the all other factors which might affect this dependent variable will be put under the u term. So that's the first thing, vagueness of theory, because you are not sure of the other factors which might affect your y or which might affect your consumption, but you know that there are certain other factors. You know that there are certain other factors, but you are not able to list it out. In such cases, what you can do is you can add a u term to acknowledge that income is not the only variable that is affecting your consumption. That's the first thing. Okay. Now the second one is unavailability of data. Actually, what happens here is, see, if suppose you are not vague, you know what are the different factors that are affecting your consumption uh, beyond your income. Okay, there are other factors. You know that there are some other factors that are affecting your consumption, but the problem is that you don't have data. For instance, you know that the family wealth, the inherited family wealth might affect your consumption pattern. But my question is, from where will you get the data for this? Here you know that this is one of the strongest factors. Family wealth is one of the strongest factor, you know that, but there is no sufficient data. You cannot have a very concrete data on that particular variable. So there are so many instances where you know that what are the factors that is affecting your consumption or what is affecting your dependent variable, but the problem is you don't have data. So in such case also, what you can do is you can add u term or you can add error term. Now, the third one is there might be core variables and there might be peripheral variables. That is, see, consumption expenditure, in fact, it will have a bearing on the size of the family. It might be having a bearing on gender. Like it's a common phenomenon that sometimes male folk may consume more than female. That's a notion actually. Religion might affect your consumption pattern and expenditure. Education might affect your consumption pattern. Geographical region can affect your consumption pattern. So there are many variables. See, besides income. Okay, so income, since income is the most strongest factor, we have put it as x1. See, now based on the strength, we have given it as x2, x3, x4, x5. Okay, now the problem is, see, if you add all these to the model becomes so complicated and you will have to collect data on all these aspects. So that becomes more complicated, more Herculean task. So what we do is we just add the most strongest factors and all the other factors are put under the umbrella term, that is a U term or the error term. Why? Because once if you put it individually or once if you introduce these things to the model, you will have to collect data. You will have to support all this with the help of concrete data. It might not be possible, maybe because of the second reason, that is the data might not be available. So what you have to do is you will have to categorize it as core variables and peripheral variables, that is strong variables and weak variables, and it is sufficient that you just put into or use just introduce the core variables to the function, and then these peripheral variables you can put it under the u term. Okay, so that is core variables and the peripheral variables. Then the intrinsic randomness in human behavior. See, actually, we human, actually, for us, we don't know actually in what way we'll be responding to different situations. There is randomness. Sometimes I might be happy today. You might ask me a question. I'll be very much pleasantly answering to you, but that might not be the case tomorrow. If I'm not in a good mood, I might not be dealing with any kind of questioning, or I won't be, might be hesitant to give you true data. So actually, human behavior is unpredictable. So in case the data that deals with human behavior, always it's wise to put all those things under the U term. Now, next one is poor proxy variables. Poor proxy variables means here in this case, when you are collecting data on consumption and income, you might get to an extent, you might get a concrete data on your income, but about your consumption last year you might not be able to give a very good data on what or how much you have spent on your consumption last year. So what we do is, instead of collecting the last year's data, what we do is we collect the data on current consumption and current income. That is, you are replacing. What we actually need is the permanent consumption and permanent income. That's what the data we need. But the problem is, what was your consumption expenditure yesterday and what is the consumption expenditure you will have tomorrow, that is in future. Both these are, it will be difficult to get actually both these data. And so what we do is we'll just replace this with our current consumption and current income. Now what happens is, this might not be a true representation of this. Actually, what we needed was permanent consumption and permanent income data. But since it's difficult to collect, we have replaced it with the help of current consumption and current income. And now what happens is this will not be a true representation. See, you cannot compare the consumption expenditure you had in 2020 with that of 2019. What happened in 2020? Actually, the whole world was stuck with the COVID-19. Our consumption pattern changed. Our income pattern changed. Now, what happens is when you are studying the consumption and income pattern of 2019 with the help of current consumption that you had in 2020, actually, there are chances that the analysis might go wrong. So when you try to replace the data, we have issues. So what we do is such kind of variables can be included in your U-term. And then the last one is principle of parsimony. Actually, this principle has got nothing to do with econometrics. This is a universal principle which says that keep simple, whatever be the model, keep it as simple as possible. So if you are introducing all these x1, x2, x3 into your regression model, the model becomes complicated. Okay, it will be complicated to estimate the parameters. So what you can do is you can keep the model as simple as possible, but it does not mean to exclude the relevant or important variables. So what you can do is you can include all your important variables, but if you think that certain other factors are least important, what you can do is you can just keep it under your U-term. So for all these reasons, actually U-term is very much important. So this is the basic difference. That is, this stochastic disturbance term marks the basic difference between your second and the third step. That is mathematical model and your economic model. Okay. Now going back to our slides. Okay, so this is our third step, specification of econometric model, and we have been discussing on U-term. Why do you need to have U-term? So in simple terms, U-term just attempts to bring under its ambit all other factors which might affect your dependent variable other than your independent variable. So what is the basic difference between your economic model and mathematical model is the introduction of this U-term. And I have explained to you with the help of my Word document why is this term important. Okay. Now, next is we have the fourth step is obtaining data. Okay, we will have to obtain the numerical values of parameters. Which are our parameters? A and B are parameters. So for parameters, we need the numerical value. So for this purpose, we need to have data. So when speaking on for data in the context of econometrics, basically there are three types of data. One is time series data, the other one is cross-sectional data, and the other one is pool data. Might be you are familiar with this, but I'll just give a brief explanation. Okay. Actually, what is time series data? When you have got the data with regard to a value or a variable over a period of time, it is known as a time series data. For instance, if you have got the rate of unemployment over last 10 years, okay, what is the variable here? It's the unemployment here. And for this particular variable, if you have got data over a period of time, say for last 10 years, this is known as time series data. Actually, what is the advantage of time series data? Time series data will help you to understand how this variable has been performing during the last over a period of time. For last 10 years, what was the rate of unemployment or how it has been progressing. So you will be able to know what has happened with this particular variable. So this is known as time series data. That is, another example is share price over a period of time. So you will be able to know how the share price has been fluctuating, whether it has been coming down or going up, or whether it was following a stable pattern, that you will be able to know. Okay, so that is known as time series data. So in case of time series data, you have data over a period of time with reference to a particular variable or a unit. But the problem with time series data is we have the problem of stationarity. See, it's too early to explain to you what is stationarity. Okay, stationarity is a bit complicated term actually, but I'll just make an attempt to explain to you in simple terms what does stationarity mean. Okay, see, this term actually evolves from the much familiar word station. We might all have heard about our bus station, railway station, etc. Right? The bus comes and goes, train arrives and departs, but the station remains as such. No, it does not move. It remains fixed. So stationarity also means the same. Stationarity is the feature of being uh, the same over a period of time, or it specifies a lack of shift or changes. Now, what is the problem here is, see, when we are dealing with time series data, you might be heard about this one, that is time value of money. What does time value of money says? Over the passage of time, the value of money changes, and the worth of rupee earned today is worth more than a rupee that is earned tomorrow. So over passage of time, everything changes actually. Okay, so even when you are talking about the share price or unemployment rate, we know that the pattern changes. But actually, the time series data in case of econometrics assumes that it should not change. The statistical property of the data, that is mean, variance, standard error, all should remain more or less the same over the period of time. Actually, in real life situation, that is not possible. And it's our Herculean task, it's a challenge to make sure that the data that we are dealing with is stationary, is more or less the is exhibit same statistical property over a period of time. There are many different ways to ascertain whether data is stationary or not, and the simplest one is you can just plot the data on a graph paper, and if it shows erratic movements, it shows that the data is not stationary, and we have so many tools to make this data stationary. So time series data has got the advantage of exhibiting or showing us what has happened to a variable or a unit over a period of time, but it poses the greatest challenge of the problem of stationarity, because over the period of time, over passage of time, nothing remains the same, everything changes. But here it is assumed that that should not happen. So problem of stationarity is the problem when we are dealing with time series data, but we have statistical tools to make the data stationary. But since that's a very big topic, I won't be elaborating on that now. So just understand that time series data is a data of a particular variable which exhibits what has happened to a variable over a period of time. Now coming to cross-sectional data, here actually what we have is, we have more than one unit of variable, and at a particular point of and at a yes, I'll give you that. Okay, I've seen a message on tools of stationarity. I'll just give you during the question and answer session. Just remind me. Okay. Yes, now coming to cross-sectional data. See, cross-sectional data actually deals with more than one variable. In case of time series data, we had only one variable and we had data for over a period of time. And in cross-section data, we don't have one variable, we actually have more than one variable. Like here in this case, I've put an example for labor productivity and wages. Labor productivity is one variable and wages is another variable. Okay, and we look into these variables as to what has happened during a particular period of time. Time series, you will present data for a number of years, but here in case of cross section data, you will not deal with number of years, you will deal with number of variables, and you will see what has happened to these variables at a particular point of time. That is cross sectional data. Now, what is the problem of cross sectional data? In fact, is problem of heterogeneity. That's a major problem that we have with cross section data. That is, see, you can never compare an apple with an orange. Okay, you can never compare an apple with an orange, and that happens here also. See, labor productivity and wages cannot be compared. And not only that, if you are giving labor productivity of different states, see, the productivity of Kerala is not at all related in any way to the labor conditions that we have in Delhi. So there are so many heterogeneous factors that might affect the relation in the data. So the problem of heterogeneity is a major concern that we have when we are dealing with cross-sectional data. And not only that, see, in case of time series data, it will help you to understand the nature of a variable over a period of time. But here it is not possible. Why? Because you are dealing only with a particular point of time. So you can only study what is happening now. or you can only study what is happening at a particular point of time, but you will never be able to understand what was the dynamics in the past or what has the changes that has happened over a period of time. That is another demerit of cross-sectional data. And pooled data is in fact a combination of these two. You combine time series and cross-sectional data. Since cross-sectional data has got major drawbacks, in econometrics, we'll be dealing only with time series data. Okay, clear? So that is with regard to data. Now coming to estimation of econometric model. Now we have data, we'll be moving on to estimation. Okay, we'll be making an attempt to estimate our parameters. See, basically, regression analysis is a tool that we use for this. Regression analysis, you might be clear, you have learned in your statistics what is regression analysis, what are the different methods of doing regression analysis. Okay, now that is the tool that we use, and we have three methods of estimating the econometric model. That is, we have three methods of finding out what is the value of slope and intercept, or what is the value of A and B, or what is the value of alpha or beta. We have three methods. One is ordinary least square method, which is simply known as OLS. Okay, OLS. It is known as OLS method. We have got maximum likelihood method, and also we have got methods of moment. I have a question regarding stationary. Okay. Okay, now maximum likelihood and methods of moment. See, due to the properties of these three methods, OLS is the most preferred method because it encompasses in itself the blue property, that is the best linear unbiased estimate. It is one of the best linear unbiased estimate. But then you will have to be very much clear about the assumptions of OLS. Okay, I don't know whether I have the time to share with you all this, but then I'll make an attempt to explain to you since it's very much necessary to know what is OLS and what are the different assumptions. I'll just make a brief explanation of the assumptions of OLS. Okay, actually I'm running out of time. Allotted only 45 minutes, but then I'll try to stop my presentation within the time allotted. But then see, what's the first assumption of OLS? OLS requires that the parameters should be linear, which means that power of the parameters should be 1, not more than that. That's what is meant by linearity. This assumption does not hold true for y and x. Y and x, whether it is linear or non-linear, that's not an issue, but your parameters should be linear. Okay, now the second assumption is the observations, that is you have collected data, and that should be based on random sampling. Okay, rather than convenient sampling, you should have used random sampling for collecting your observations. Okay, and another task is that number of parameters should be greater than the number of observations that is taken for making the linear regression model should be greater than the number of parameters. Suppose if we are estimating 2 parameters, the number of observations should be greater than 2. Okay, because if it is less than 2, it makes no sense. If we have got 2 parameters to be estimated, and if your observations are less than that, it doesn't make sense. And if it is just equal to that, actually you need only algebra. You don't have to make a regression analysis model. So always make sure that the number of parameters, sorry, the number of observations should be greater than the number of parameters. I think someone's mic is unmuted. Just mute. Now, the third one is the x should be fixed. That is, the independent variable should never be influenced by your dependent variable. That is, y should in no way affect your x. So if suppose in any case, if y affects your x, x will lose its identity. What we call x, as we call x as independent variable. Suppose if y goes to extend its influence on x, what happens is x will lose its property of independence. So you'll have to make sure that when you are placing these variables in your function, make sure that the variables that are put under x are purely independent. Okay, in no case there should be a correlation between the two variables. Okay, so that should never happen. happen. So you will have to make sure of that. Then comes the assumption of conditional mean, that should be 0. That is, in very simple terms, the distribution error terms, there must be no relation between x and the error term. See, in this model, let's take the equation. See, can you see this equation, this x? Okay, this x and u, that should never be related. There should be no relation between these two, because once these two have a relation, there are chances that x will lose its independent status. So always make sure that when you are adding variables under this umbrella term, make sure that will not exert a strong relation between or a strong influence on your x variable. So that is, make sure that your conditional mean is 0. Okay. Now, next one is there is no multi-collinearity. What does multi-collinearity mean? Actually, this is a problem only when you are dealing with multiple regression model. See, if you have got only a simple regression model, see, this is an example for simple regression model. Why? Because you have only one x here. Suppose you have got more than one x, 3, as I explained to you earlier. Actually, that is a case of regression model. In that case, you have to see that there is no relation between these x2, x3 and x4. Okay, so make sure that there is no multi-collinearity, and this is a challenge only in case of multiple regression model. In case of single regression model, this is not at all an issue. Why? Because you have only one independent variable. So there is no question arising of whether there is a relation between the independent variables, because you don't have independent variables. You only have one independent variable. Okay. Now that's it with regard to multi-linearity. And then fifth one is homoscedasticity and no autocorrelation. What is homoscedasticity means? It means that the error terms, especially with reference to autocorrelation, the error terms of one year should not be dependent on another. See, for example, when you are dealing with unemployment rates, normally what happens is the unemployment rate of 2021 will affect, automatically it will have an influence on the data that is collected in 2021. Okay, so there will be a relation. So such kind of relations, make sure that such kind of correlations are absent. Okay, so that you have to make sure. And with regard to homoscedasticity, it means that the variance of the term is constant. Error terms. Hello. Okay. And also you'll have to make sure that the variance, the error terms are constant, which means that, see, as and when your predictor variable changes, okay, as and when your independent variable changes, it must not cause a change in your error terms. Okay, so you'll have to make sure of that. That's what it's been said, that homoscedasticity, that is the variance of the error terms should always be constant. Okay, now the last one is not much important. Error terms should be normally distributed. Actually, this is not compulsory. It is good if it is there. Otherwise, also OLS can work out. Okay, so the first 5 assumptions. Okay, first 5 assumptions you'll have to bear in mind while you are dealing with the estimation. Okay, so once again, I'll just brief it up. First is linear in parameters. That is, the power of parameters should not be more than 1. And assumption 2, make sure that the data that you've collected is random. It is not based on some kind of non-probability sampling methods or convenience or judgment like that. It should not, as far as possible, make sure that it's random sampling or probability sampling methods you have used. And the number of observations is always greater than the number of parameters. And also x should be fixed. That is, y variable should not exert its influence on your x variable, because if such a thing happens, we cannot call x as the independent variable. Okay. Now, the third one is that the conditional mean should be 0. That is, the error terms should not depend on your x variable. So there should be no relation between your x and the error term. That is, there should be no relation between your one of the main important independent variable with that of your error terms. Okay, so there should be no correlation like that. Next is You'll have to make sure that there is no multicollinearity. And I have said, see, this is a problem that we have only in the case of multiple regression model. In case of simple regression model, we don't have such an issue. Actually, this speaks that when you are adding more and more variables into your equation or into your model, make sure that these variables do not have a correlation. It do not depend on each other. Okay, so that is there is no multicollinearity. You will have to ensure that. And finally, the last one is assumption of spherical errors. Two things: homoscedasticity and autocorrelation. You'll have to make sure that your error term and your x is not related. That is, error term should not be dependent on your x. If it is dependent on x, what happens is, as an x is an independent variable and it might change now and then. Now, if this is dependent, what happens is, along with x, the error terms will also start changing. So that should never happen. You will have to make sure that your error term is not dependent on x. And so for that, you will have to compute the variance and see to it that its variance of the error term is constant. This is known as homoscedasticity. And autocorrelation means it's a relation between the error terms of different years. There are chances that the data of 1 year might exert an influence of the data on the coming next year, but this will exert a limitation on our estimation. So see to it that the data of 1 year is totally independent with the data that we have during the preceding or the succeeding years. And finally, the last assumption, that is, error terms should be normally distributed. Actually, this is not necessary. Even if it is not complied with, OLS will function. Okay. So this is with regard to assumptions of OLS. Now, coming back to our PowerPoint presentation. Yes. See, sixth step is testing of hypothesis. You might know well, actually, methods of basically two methods, parametric and non-parametric. You might be knowing what are the situations or contexts why we might be using parametric and non-parametric. Actually, that's a long topic. So I believe that you have a knowledge of hypothesis. So step is hypothesis, and the seventh one is forecasting. Once you end up with testing of hypothesis, you either accept or reject the hypothesis. So that gives you an insight for forecasting or making predictions for the coming year. And this is prediction used for making actually decision making of a policy purposes. And I apologize. Actually, I was check my Word document. I think it was not visible to you, right? I was trying to share my Word document actually. Can you see my screen now?
No, ma'am.
No, madam.
Okay. Just wait. Yes. See, this was the assumptions that I was explaining. Could you see this last time when I was explaining? These are the assumptions of OLS. Okay. If you want, I'll share this content with you. And I'm going back to the PowerPoint presentation. Yes. So in the step, with the help of OLS, we have estimated the parameters, and sixth step is testing of hypothesis. That's what I have been mentioning. See, testing of hypothesis is in fact a very different area. It's a very large area. We will need another 2 or 3 hours to deal with that. But I hope that you will have elementary knowledge of testing of hypothesis and different methods of testing. Broadly, we have two methods, parametric and non-parametric. Parametric, the most important methods are T, Z, and all, ANOVA. And non-parametric also we have chi-square, run test, test, sign test and all, we have non-parametric test. Okay, and once we have tested with a hypothesis, once we have accepted or rejected a hypothesis, that can be used as indicator for forecasting or predictions in the coming years or the coming time. And this forecasting or prediction is used for policy making or decision making. Okay, so by this I am one presentation because almost it's time up, I think. Now the session is open. If you want to ask me something, you can just ask me on that.
Thank you, ma'am, for your valuable session. Now it's time for discussion. The questions in the chat box will be discussed, but before that, if anyone have doubts and queries, I request you to unmute the mic and ask the questions.
Good evening, madam.
Good evening.
Dr. Rajendra, City, Vijayawada. It's wonderful. Your
Okay, so your voice is so fizz.
okay.
Sir,
Now, am I
can you
audible,
be a
madam?
little more louder? Ah, yes, yes.
Am I
Now I
audible,
can hear
madam?
you better. Yes, 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 yes.
I am Dr. Rajendran from KL University, Vijayawada.
Okay, sir.
It's wonderful that your expertise shows that how better flow is very confident. And my question is that a non-mathematical fellow, how can he understand econometric model better in a better way? What would be the better preparation a non-mathematics student, a non-mathematics fellow can better
Sir,
in
actually,
econometrics?
it's a wrong notion that to understand that econometrics can be dealt only with the mathematician. It can be dealt even with others. Actually, economics is our subject. It's a subject from social science.
Okay.
And
Okay.
statistics also, we have a basic knowledge. And now coming to tools, like for example, someone asked me, how can you test stationarity? See, there are different tests for that, like unit root test, Dicker Fuller test. These are the different tests that we use for doing or testing the stationarity. Actually, we'll have to understand that none of these tests are done manually. We have different softwares to help us. What we need to have is only the knowledge of what to do in a particular context. See, for example, we have parametric and non-parametric test. See, you must not be, everyone might not be sure about the steps that you do for this test. What you need to do know is in what or in which context, which test is to be applied. Once you know that, your softwares will help you for that. So understanding of the concept is much more important than the knowledge of doing the stepwise things. You know, we have different, like Gretel is one of these software. To understanding of concepts, I think it's not only a mathematician can do, everyone can. Even I think economics will be difficult for us. We have a wrong notion that economics can be read fully with mathematics. Actually, this paper is not mathematics. It's a combination of all this.
Yeah. Thank you, madam. Thank you.
Okay. Thank you.
There are some questions in the chat box also. First question by Sanish. Can you specify the two?
Am I audible? Ma'am, I have a
Yes.
question.
Yes, sir.
Ma'am, you said that you cannot find, you can only find for the particular time only you can find the variables. You can use the variables. You said like that. But in some cases, can we use equations with a real life example and can differentiate between a time period?
Actually, are you talking about data?
Yes, ma'am. Data. So we can use that to find the results using uh, in real time. But not only you said you cannot use for you can use only in particular time. You said no, ma'am. So I have doubt. We
No,
cannot use
no,
it
no,
for.
no, no. I didn't mean to say that you can only. No, no, I didn't mean to say that. What I told you is that, see, cross-section data deals only with the data at a particular point of time. See, if you are
Oh,
taking labor productivity or wages for 2020, you will be dealing only with that particular year.
oh,
Whereas in case of time series, you will have a data for a large number of years. So what I mean to say that when you are dealing with at only a particular point of time, you will be able to look into what's happening now, but now or what's happening during a particular point of time. But then you will not get an idea of what has happened over a period of years. See, when you have data with regard to unemployment in 2021, you don't have data for previous years. So whether the unemployment has increased or decreased over the years, you won't be able to make a true judgment because we have data only for a particular point of time. Whereas in case of time series data, since you have data for a particular variable over a period of time, that is for a number of years, actually, you can understand or you'll be able to know actually what has happened to this variable over a period of, that's what I mean to say.
okay, okay,
I was just explaining the merits and demerits of both these types of data.
okay, okay. Thank you.
Okay, okay.
Thanks a lot.
Thank you. Thank you.
There is a question in the chat box by Sanish. Can you specify the tools used for ensuring stationarity in data?
Stationarity actually one of the most prominent tests, and it is one of the first statistical tests that was developed was actually decay Fuller test. That is the most prominent test to ensure that there is stationarity. Instead of that, you can also go for simple techniques. That is, if you have got a data with you, just plot it in a graph paper. Okay, so if you see erratic movements there, it shows that the data is not stationary. So there are so many methods, and decay Fuller test actually it has got a very complex formula. And just as I have mentioned earlier, actually don't be concerned about how this is worked out. Your softwares and your programs, computer programs will help you with that. Only thing is that you will have to know what are the tests for available in econometrics. As when we deal with our research methodology, as we have got different tests to help with our hypothesis, like chi-square, t-test, z-test. We have so many tests in econometrics, like Jarque-Barra test, unit root test, decay Fuller test. These are different tests that we have in econometrics to test this stationarity, to test validity. It is true that being people from the social science background, for us, it will not be so easy to work it out. But then there are so many computer software programs that will help us with this.
Okay, ma'am. Next question by Somnath. Question regarding stationarity and non-stationarity, which is very important to conduct financial econometric models.
Yes. See, that's a very vast subject. If you want, I'll just share with who has asked this question.
Somnath.
Who has asked this? Who is it? See, stationarity itself, there are different levels of stationarity. First line stationarity, second line stationarity, all these things. It's a very vast subject. If you want to have a session on that, say you can just mail me. I'll just give you my mail ID so that I can share that with you. I have the materials with you. I can share it with you, and we can do it in a platform other than this, because I think so many people are leaving. Now only 55 is left. That's 810, and I won't be able to explain it without the material, because there are so many pictures, there are so many figures with which I can explain the concept of stationarity and how it can be tested. I'll do that. Yes, yes. I had seen the mail ID. I'll share with you, and also you can call me on my number if you want to have more discussion on that.
Okay, thank you, ma'am. Due to time limit, we are cutting short the Q&A session. Remaining queries can be forwarded to the mail ID. Thank you all for your active participation and keen listening. Now, I invite Brinda Vidyadharan, Research Scholar, PG and Research Department of Commerce, Government Arts College, to propose vote of thanks.
Hello. Am I audible?
Vrinda, you are audible.
Yes, Brinda, you are.
Good evening to all. On behalf of Research Forum, Government Arts College, first of all, I extend my most sincere thanks to our resource person, Dr. Daisy Samuel, for taking out time from her busy schedule to grace the event. She explained the topic in very simple, meaningful, and thought-provoking way. I also wish to express my gratitude his solid support and timely monitoring in every aspect, especially for delivering the welcome address. I thank all the faculties of our college and research supervisors from other colleges who supported and provided their guidance and encouragement in all our efforts. I would like to give my hearty thanks to all the research scholars who have greatly helped us in this program. Finally, I would like to express my deep gratitude to all our participants in the program. You are the reasons for the successful journey of our web series. Once again, I thank all of you for the immense support. Thank you.
Thank you, Brinda. Now it's time to wind up our session. We will share the PPT in the WhatsApp group. The feedback link is provided in the chat box and it will be
Yes. Okay. I had given the mail ID. If someone wants to communicate, you can use that. Okay.
okay. Feedback link is provided in the chat box and it will be active only for 20 minutes. So kindly fill it out